about last time is finding average rate of change, right? And we said we did that by picking 2 points on a graph, connecting those 2 points with a line, like this black line here, and that becomes a secant line. All right? Now, that tells you the average rate of change. So the rate of change between this and that point, and that's just the average rate of change. However, if I want to find the rate of change, not over this entire interval, okay, but just on one point, we've kind of touched on this before, then I can't take a secant line. What I would have to do then, like in this case, I selected, in the case of the black secant line, I selected 1 point here, that was A. Then I went over H units to A plus H, and I selected that point, okay? And the line in between them became the secant line, and the slope gave me the average rate of change. However, if I want to do that if I want to find the rate of change at that specific point, then instead of taking H to be that big, I take a tiny amount for H, right? So if H becomes almost 0, then A plus H is right there, okay? And then that second point is right there. So when I connect those two with this red line, then it becomes more of a tangent line and not a secant line. Yeah?
When you say rate of change what does that mean at a point?
The rate of change at a point means, so for example, if you're... yes and no. So that's the thing. So the rate of change, if we talk about like position and speed, right? Remember we talked about like driving 300 miles in 6 hours. It's like 50 miles an hour, right? But when you look at your speedometer, and if you're going, let's say 57 miles an hour, that's your speed at that point. That's your rate of change at that point. With this construct, we're finding rate of change using slope. So yes, we need 2 points. But if we have the 2 points far away from each other, that becomes average rate of change. If we have the 2 points super close to each other, then that becomes the rate of change at that specific point.
So when it's rate of change at 1 point, it's still kind of at 2 points?
It's still kind of at 2 points, but the points are really close to each other. So when H approaches 0, the slope of the secant line approaches the slope of the tangent line. So that's pretty much what we need to do. Okay? H is the distance that you go away from the first point to the second point. Okay? So for the second point, look, I have A here, and then this is the second point. So H is that distance in between. It's almost 0. Okay. Yeah.
So I see like that equation though that you have like
yeah, we're gonna get to that now.
Okay.
Yeah.
I was just like, we do that homework or whatever.
Yes. So, so to find the slope of the secant line, right up here, the slope of the secant line is y2 minus y1, right? So it's f of a plus h, that's the second value, minus f of a over h, that's the distance in between. That's the slope of that black secant line, the average rate of change. Okay?
Why is it?
Huh?
Why is it?
Because it passes the curve in 2 points.
Oh, right.
Now, to make it the slope of the tangent line, remember what we have to do is we have to make h approximately 0. So you take this same thing, but now to find the slope at a specific point, I have the same equation as before, except now it's the limit as h approaches 0 of that same equation. So that's the same equation we just wrote up there. But now when I add to that the limit as h approaches 0, it becomes the slope of the tangent line. And with that, I'm able to find slope or rate of change at a specific point. Okay, very quickly.
Sarah's not here and she wanted me to remind you to record.
Got it, doing it. Okay. Okay, so this is how you find slope at a specific point. Okay, so take a look at this next one. We want to find the slope of the parabola y equals x squared at the point 2 comma 4. So right here at that point, I want to find the slope. What does that mean? At that point, if I were to draw a tangent line, the slope of that line is what I'm trying to find. Okay? But we're not going to draw a tangent line. We're not going to do it that way. We're going to do it using the formula. All right. So what we have to do is we have to find the slope of the tangent line.
But we don't know. We don't have an h.
It's okay, because here's what we do. So m is, we don't need the h. M is the limit as h approaches 0, f of a plus h minus f of a over h. Now, if you have to do this at the point 2 comma 4, that number here, that 2, the x value is your a. Okay? All right. So always. So now, m is the limit as h approaches 0. F of, now a is how much? 2. 2 plus h minus f of 2 all over h. I haven't done any math right now. I've only substituted 2 for a. Now, let's try to do these. Okay, so this is the limit as h approaches 0 of, okay, f of 2 plus h. Let's do this. This is f of x. F of x is x squared. F of 2 plus h is 2 plus h squared. Minus f of 2. Okay, so take a look here.
Why would it not be f2 squared? Oh, because
Okay, f of x is x squared.
yeah.
F of x is x squared. F of 2 plus h is this. Now I'm going to do minus f of 2, which is going to be 2 squared. All over h. Okay, now we do the math. Here, I'll do it here. Limit as h approaches 0. The red one, okay, very important. Now that we're in calculus, we're never going to forget this ever again. When you have a binomial, 2 plus h squared, you're going to end with 3 terms. Square the first term, square the last term. In the middle, you get 2 times h times 2, positive 4h. If you have questions on that, you got to come to bonus. Minus 4. Oops. All over h. Okay, this is equal to the limit as h approaches 0. 4 and minus 4 go away. So now I have 4h plus h squared over h. Now, limit as h approaches 0. I can factor out an h from the top, right?
Yeah.
So I get h, 4 plus h over h. What happens when I plug in 0 for h now? I get 0 over 0, so I can't do that, right? But cross out the h's, and I have limit as h approaches 0, 4 plus h. Now plug in the 0, and this is equal to 4. That's crazy. So this is m equals 4. This is the slope.
Will it always be the same as the y-axis?
Oh no, it's just a weird coincidence. Okay, so that's the slope. Okay, that's great because we just did the first part of the question. The second part of the question says, write an equation for the tangent of this parabola. Let's do that now. Equation of the tangent line is, okay, We have a slope, we have a point. What's the point? 2 comma 4, and the slope is 4. So, it goes back to, what we were doing before. So y minus y1 equals the slope, x minus 2. You can totally leave it like that because this is calculus and that's totally fine. Or if you really like y equals, mx plus b form, y-intercept form, it'll be 4x minus 4. I really don't care which one. However, the more steps you add, the more chance to make a mistake and the more chance to lose points. So just, Okay, unless it specifies, just leave it that way.
So the answer is the slope and this, or just?
Yeah, it asks for 2 things. So first find the slope and then find the equation of the tangent line. Okay. So it's a lot of steps. You have to take your time and do them, right? Like one by one. Don't skip too many steps. The more you do them, the more you'll see that there is a pattern to all of it. Okay. Yeah.
Okay, so these questions kind of take, I would say, a little bit of time. So is there gonna be like one of these questions on the test, or is there gonna be
Like 1 to 3. Somewhere between 1 and 3.
so 2?
But it's okay, because the whole test will be made so you can take it within 50 minutes. Okay, let's do this. The more you do it, the quicker it gets. Okay? All right. Let f of x is equal to, let f of x equals 1 over x. We're going to find the slope of the curve at any point A. This time is at any point A, not necessarily like, you're not given a specific point. Where does the slope equal negative 1 over 4? Okay, so here's what we're going to do. Part A. The limit, so m equals limit as h approaches 0, f of a plus h minus f of a over h. Okay, so m is limit as h approaches 0. Now, f of a plus h, if f of x is 1 over x, f of a plus h is how much? 1 over a plus h.
Wait, where did you get that?
Because it's f of a plus h minus f of a.
I know what A is.
Wait.
F of A.
You're not supposed to know.
Okay, f of x, we're given in the problem, is 1 over x. Now we need f of a plus h. So that's 1 over a plus h. Okay, minus f of a, that's 1 over a. All over h. Now, that's a complex fraction, right? I've got a fraction on top, fraction on the bottom. I want to simplify that fraction. The easiest thing to do is this. We're going to multiply top and bottom by the same thing. And you've been doing similar things in the last chapter. The common denominator in the top is a plus h. So we multiply top and bottom by a plus h. Okay, now, and the bottom too. So m is limit as h approaches 0 of, okay, you see how instinctively I always create the main fraction line and then I fill in the top and the bottom?
Yeah.
So I'm going to multiply this first term by the stuff in the red, and I'll just get how much left? A. Minus, now I'm going to multiply the second fraction by the red, and what do I get left?
A plus H.
A plus h in parentheses. All over h times a plus h. Do not multiply that stuff out. Okay, now this is the limit as h approaches 0. Let's just distribute the negative. A minus h over a plus h. A minus a goes away. So I have, what do I have on top? Negative h over a plus h. So again, if I plug in 0, I'm going to get 0 over 0. But look, the h's cancel out, just like they did last time. It's like black magic. Every single time, the h's are going to cancel out. And then I have left limit as h approaches 0, negative 1 over a plus h. Now what? You know. Plug in the 0. So now I get negative 1 over a times a plus 0, negative 1 over a squared.
And you have to put.
This is.
Wait, doesn't 0 go to, doesn't 0 become an a value?
No, it's h approaches 0, so it goes to h.
Oh,
so it becomes a times a, which is a squared. Now, the h, please put your phone away. The h is a variable that we artificially, introduce into the problem when we're doing the, move h units away, move h units back, that sort of thing, okay? Because it's something that we artificially inserted into the problem, at the end of the calculations, it's got to go away. That's like a mathematical rule, okay? So every single time your h is going to go away. If the h doesn't go away, there is something wrong. So you got to go back and redo the problem, okay? All right. Okay, now part B. So this is the slope. This is the slope. Part B says, where does the slope equal to negative 1 over 4? Okay. The slope, I just found it. It was negative 1 over a squared. Now I want that to equal negative 1 over 4. Negative 1 over 4 equals to negative 1 over a squared. Okay, yeah. So the negatives go away. And then look. Now I have 1 over 4 equals 1 over a squared. So a trick in math is if the numerators are the same, if they're identical, then you can just set the denominators equal to each other. So a squared equals 4, and what's a? Nope. I mean, yes, 2 plus or minus 2. Okay, so let's take a look at what it is that we've done. F of x is 1 over x looked like this. Okay, and it's asking you, where is the slope? Negative 1 over 4. And we said at x equals 2 and negative 2. At x equals 2 and negative 2. So that's that point and this point. And sure enough, look, the slope at both of those points is identical, and it looks like it's negative 1 over 4. Do you see that? Like, how flippin' cool is that? Like, you can't do that with any other class, right? Like, look at that. Okay? All right. So, yeah. It's okay. You don't have to take.
Yeah, you can.
Okay. So at what point is the tangent to f of x equal to blah, blah, blah horizontal? Okay, so tangent horizontal, right? Horizontal tangent means the slope of the tangent is 0. Okay? The slope, okay. Okay, listen. All this is to find the slope of the tangent line. Okay? We found it to be 1 over 4, negative 2, whatever. Now we want the slope to be 0. And we've learned since Algebra 1 that for horizontal lines, slope is 0. So if we want the line to be horizontal, it means we need slope to be 0. Now okay, so in calculus, right? We're very efficient in calculus. So each word, the wording is very important. Each word and phrase is there for a reason. So when you read at what point, this is asking you what is the x value, that blah, blah, blah. Okay? So we want the slope to be equal to 0. Well, first we need to find the slope. So let's find the slope first. Slope is the limit as h approaches 0 of.
Yeah, I already knew the slope.
We want the slope to be 0. So we have to find the slope and set it equal to 0. Okay? We want to find the slope of this and set it equal to 0. So minus f of x over h. Okay, so this is the limit as h approaches 0 of Now take a look. This is going to be a longer problem.
Did we take the last one?
This is a longer problem.
Okay.
Where did they go?
So the actual formula from before was f of x plus h minus f of x and so on. If you are given a specific point where you're finding it, then it becomes f of a plus h and so on. It really doesn't matter. You can just leave it as, you know what, let's just leave it as a. Let's just leave it as a. So I'm going to find f of a plus h. I'm going to plug a plus h into this equation. So let's do that. 3 minus 4 a plus h minus a plus h squared minus f of a minus f of a. So let's do f of a. That's 3 minus 4a minus a squared in parentheses. All over h.
Because you're putting it into the function. You're switching out the x's with the a plus h.
Right. Okay, now let's multiply this out. So 3 minus 4a minus 4h minus, let's square that, a squared plus 2ah plus h squared minus 3 plus 4a plus a squared all over h. No. Limit. Guys, come on, please. Limit h approaches 0. Okay, let's put in the negative. So 3 minus 4a minus 4h minus a squared minus 2ah minus h squared minus 3 plus 4a plus a squared over h. Okay, when you multiply it all out, now listen. Okay, the first two steps here that I've written down is calculus. After this, what we're doing now technically is more like algebra, okay? Towards the end, the calculus will show up again. So here, you're always going to have stuff that will cancel out. So first of all, negative a squared, positive a squared goes away. Positive 3, negative 3. Negative 4a, positive 4a go away. So what do I have left? Limit h approaches 0. Negative 4h minus 2ah minus h squared over h. Now what? Factor out of what?
H.
Right. So you get negative 4 minus 2a minus h over h. Cancel out the h's. You see there's already a pattern. Every single one ends in the same way. You add and subtract stuff out. You cancel out the h's. Now, this is the limit as h approaches 0, negative 4 minus 2a minus h. Let me stop this.
No.
So what now? So what now? What do we plug in here?
0.
So what do we get?
Limit 4 minus 0, negative 4 minus 2a.
Okay. So h becomes 0. H has to go away. When you're done, h cannot still remain in the problem. It has to go away. So now this is negative 2a minus 4. I just rewrote it in different order. This is the expression for the slope for this function. So basically, let's take a look. This is some parabola, right?
Yeah.
The 3 minus 4x minus x squared, that's some parabola. This is a way for you to be able to find the slope at any given point. So for example, when a is 0, right, or when a is, let's say, 5, you put it in there and it gives you the slope right there at 5. When a is like 9, you put it in there, it gives you the slope of that number there. Now we want the value for where the slope is 0. So we say, it's not? How about at the vertex here? right? Okay, so
You're a magician. Oh yeah.
okay, so so a equals -2. What does that mean? Therefore, okay, at x equals -2, the slope is 0. So it looks like I didn't draw my parabola correctly. The x-axis should have been that way, okay?
Okay, yeah, the last
Those
step
dots
is
meet
fun,
again.
but
Therefore,
Huh?
that is
so therefore,
So the normal line, okay. So in calculus, when we say normal line, it's basically the perpendicular line, right? So normal means perpendicular. So the normal line is a point where, you have a perpendicular to the tangent, okay? All right, so look at this problem. It says write an equation for the normal to the curve. It won't even say like to the normal line sometimes. Like just saying normal, it means the normal line. So write an equation to the normal of the curve, this. Since this is the line perpendicular to the tangent, you first have to find the slope of the tangent and then get the perpendicular slope, okay? So this has perpendicular slope to the tangent. That means first find the slope of the tangent line. So the slope of the tangent line is the limit as h approaches 0 of, again, it's the same thing, right? So what are we doing here? This is the curve f of x, and we're doing it at x equals 1. That means a is equal to 1 essentially, right? So this formula is going to be, remember it was f of a plus h? It's f of 1 plus h minus f of 1 over h.
And that's just because we have this one. That's not for all of these.
Right, because this is asking you specifically at x equals 1. I'm going to take questions after I do this problem. So here we go. F of 1 plus h. So now, let me highlight. This is f of x. If you want f of 1 plus h, all of the x's are going to be replaced by 1 plus h. So it's going to be 4 minus 1 plus h squared minus f of 1 is in parentheses 4 minus 1 squared. So f of 1 plus h minus f of 1 over h. Okay, so this is the limit as h approaches 0. 4 minus, okay, when you square that, you get 3 terms. 1 plus 2h plus h squared minus 3 all over h. Okay, we simplify.
4 minus 1.
Should you keep the 4 that you can cancel it out with the other?
Nope.
4?
So okay, listen, just guys, let's wait until the end, and I promise all of your questions will be answered. So 4 minus 1 minus 2h minus h squared minus 3 over h, which means this is the limit as h approaches 0. 3 minus 2h minus h squared minus 3 over h. Now the 3's go away, right? So now if I take out an h, I get -2 minus h all over h. H's cancel, and so the slope is what? -2. Okay? So the slope is -2, but this is now slope of the tangent line. The normal line is perpendicular to the tangent, so I need the perpendicular slope to this. 1/2. So normal slope is 1/2 And we want an equation to the normal, right? We want the equation of the line. Okay, so now, how do you find an equation of a line? You need a slope and a what? A slope and a point. I have the x value to the point, but I don't have the y value to the point. So how am I going to find the y value? Easier than that. Plug in x into here. Okay?
Oh, because after x is
Yeah. 4 minus 1 squared, it's 3. So 1 comma 3 is the point. Now we can write an equation of the line. Okay, now for the equation. Y minus 3 is equal to 1/2 x minus 1. This is the equation of the normal line. Yay is right. Okay, so look. 4 minus x squared. Let's draw this for a minute. This is negative x squared plus 4. It looks like this. Okay, this is f of x. At x equals 1, here, right? This is the tangent line. Do you see that that has negative slope? The slope of that is -2. The normal line is this. It's perpendicular at that point. So if the slope of the tangent line is equal to -2, the slope of the normal line is 1/2. So that's what we've done. And this green equation here, it's the slope of that perpendicular line, right? Perpendicular to the tangent line, right? Okay. All right. Yep. Calculus was actually invented by 2 people simultaneously, independent of one another. One was Newton, and the reason why he did it is because he was also trying to figure out how to express the laws of physics, like speed, acceleration, and so on, and he needed the language to do that. Until then, there was no language to do that, like rate of change and so on and so forth. So, that's where all this came from. So naturally, like the most natural example that we normally go to are speed and acceleration and so on. The other person, there was another person, Leibniz, he also came up with like very similar things independently, like I said, at the same time. And there was like a little bit of a, like who gets credit sort of a thing. It was like a race to publish first. But so Newton is better known because he also created like the 3 laws of motion and so on. However, we'll talk later, the other guy, Leibniz, has his own notation. Okay. So of a rock falling, right? This is the position function. Okay. What we're going to do right now, right, is we're going to find the speed of the function at a specific point. That is called the instantaneous speed, right? This is the rate of change of position with respect to time, but it's at a specific point. So whenever you are asked to find instantaneous speed, this is the formula with the limit as h approaches 0. Okay? So now look at this here. You're asked to find the speed of a falling rock at t equals 1 second. Okay? You're not asked to find average speed. It's speed at a specific point. This is instantaneous speed. Okay? So we're going to use that formula. Yeah. So we're going to say, okay, speed is limit as h approaches 0. F of t plus h, that's going to be f of 1 plus h minus f of 1 all over h. Okay, so this is 16 times t squared, 1 plus h squared, minus 16 times 1 squared, all over h. Yeah.
What's the variable for speed?
It could be v.
Okay.
It's usually v
Like
for velocity, right?
Yeah.
So this is limit as h approaches 0, 16 times 1 plus 2h plus h squared minus 16 over h. I'm going to let you foil that one and figure it out. So 16 plus 32h plus 16h squared minus 16 over h. You see how things cancel again? It's like black magic. This cancels with this. Limit as h approaches 0. You know what? Let me just factor out an h from here. 32 plus 16h over h. These go away. There is no need to because one of it is going to be 0. Yeah. So 32 plus 16h, and that will be 32. So the speed at 1 second is 32, units per second, or like meters per second, miles, whatever, okay? It'll be, since it's 16, it'll be feet per second.